Okay, hi. So this video, I'm going to go over those three exercises, right? So that's the first one, a 15-foot ladder. So we know that this right here is 15. It's linked to a wall 9 feet from the ground. So we know that this one is 9, right? Find the angle of elevation from the ground. So that means that we want to find the angle. So we know that this value is named that one right here, theta. That value is going to be positive. It could be a decimal, but we know that it's going to be positive, right? So in this case, from the angle, I have the opposite and I have the hypotenuse. So that means that I gotta work with sine. So sine of that angle equals to 9 over 15. So in this case, I have to use the inverse function. So theta is gonna be sine -1 of 9 over 15. So finding that on my calculator, this is 36.9 degrees. Now, my second one is telling me a tourist guide laying down the edge. So we know that the tourist guide is someplace right here. It's laying down right there, right? Sees a cat with an angle of depression of 55 degrees. So we know that the angle of depression, my angle of depression is this one. So this one is 55 degrees, right? We know that this is right. Now, because that one is 55, we know that this one is also 55, right? And it says if the cat is standing 250 feet from the base of the cliff, so that means that this is 255 feet, right? And I want to know how high is the cliff. Again, that has to be positive, and it can be a decimal, so I'm finding x. Right? So in this case, I'm not using sine, I'm going to use tangent. Why? Because from the angle, I have the opposite, and I have the adjacent. So that means the tangent of 55 equals to x over 215. Right? So here I'm going to multiply times 215 on both sides to cancel out that. So I'm going to just find that on my calculator. This is 207.1 feet. Now, the next one says from a plane flying due is, so we have, let's try to draw a plane here. We have a plane right here. It's flying due is, so we know that it's flying that side, right? That is 600 feet. So we know that this is 600 feet, right? It says that it sees two cars. So let's try to draw the first car right here. And the car is right there, right? 2S. And then I know that my other car is somewhere around here. Uh, Something like that, right? And we know that this side here, and that side here, and right. So it says that the pilot sees two cars driving due east with angles of depression of 42. So let's start with that one. So we know that this angle is 42, right? So with that information, we know that this one is also 42 degrees, right? So I'm going to use that information to find A. So I'm going to find that distance first from just that point below the plane to the car. So to find that distance. So in this case, I have tangent of 42. Again, I have tangent because I'm working with opposite over adjacent equals to 600 over A. I'm going to multiply times A on both sides. So A tangent of 42 equals 600 divided by the tangent of 42. So A equals to 666.4 feet. Right? So now I'm going to find the distance from that plane just below the plane to the second car. Right? I know that this angle here is 30. So that means that this one is also 30 down here. So let's name that B. Again, I'm using tangent because I have the angle. I have the opposite, and the adjacent. So that means that tangent of 30 equals to 600 over B. Right? I'm multiplying times B on both sides. So B tangent of 30 equals to 600 Then I'm going to divide by tangent of 30. So b equals 2. 1039.2. Right? So now I know the distance between the point just directly below the plane to the second car. I know the distance from the just below the plane to the first car. Now to find that distance between those two cars, so let's name that D. I'm just going to subtract those two. 9.2 minus 66.4. So this equals to 372.8 feet, and that's the distance between the two cars.